Okay, so this class, or this week, we are preparing for the final exam. It's a week from today, Tuesday. Today, I'll answer any questions you have from the final exam study guide, which is over here on the side table in case you don't have one yet. It's also posted in Moodle. So I'll answer any questions you have on that, and you can spend some time working on that if we finish all the questions that you have. You should also create your 2 cheat sheets for use on the final exam. So you can use those 2 sheets, and you can use your packet of reference sheets, okay, that pink packet. And all the reference sheets, I might have 1 or 2 left, but they're also all posted in this reference sheets folder. So you can get any ones that you want there. Okay, so today, answering questions and working on the study guide. Thursday, we're going to take a practice final in groups. Okay, so it's 5 or so questions, but multiple parts per question. It'll be open notes. I want you to look things up if you don't know them yet. That's part of the practice final. But it's also a good time to sort of have your cheat sheets out next to you and try to just reference your cheat sheets. And if there's something you need that's not on it yet, add it to the cheat sheets. So probably a good idea to try to either have them done for the practice final or make them as you're doing the practice final. Okay. So that will be a 6th quest grade. If it raises your quest average, we'll use it as a 6th quest grade, and if not, we'll just drop it. Okay. But it should help you. Okay. And then Tuesday is the final exam. The final exam is nearly cut and pasted from things that you have already seen. The 5 quests, the practice final, and the study guide for the final exam. May not be identical, like I may have changed some numbers or added a part to a question that you've already seen, but for the most part, it's all going to look very familiar. Study your quizzes, study your practice final, and study your study guide. 10 questions, multiple parts. I think the shortest one has 2 parts, and the longest one is like A through E or something. 5 parts. For the final exam, like with most things, I'm not going to kick you out at 10:30. You can take like up to another hour if you need it on the final exam. Same thing with the practice final. If you guys want to stay late, that's totally fine. We have sort of 3 vocabulary words surrounding growth rate. Right? So we've got effective annual rate, we've got annual rate, sometimes called the nominal rate or APR, right? The effective annual rate is sometimes called the APY. And then we have the continuous annual rate. Okay, so all of these phrases have the word annual rate in them, so it can be very confusing of which one's which. Okay, so we have 2 different formulas for how to calculate interest in an account, right? So we have for effective annual, for annual rate, or the nominal rate, or the APR. That comes from this formula. Where P is your principal, your invested amount, R is your APR or your nominal rate or your annual rate. Okay, when they say continuous annual rate, that comes from this formula. PE to the RT. Okay, so the R in this formula is called a continuous annual rate. The R in this formula is just your annual rate or your nominal rate or your APR. And then effective annual rate, you can calculate from either of the other 2. So that's something that you calculate. This is the percent growth in 1 year. Okay, so there's no formula for that. You just have to calculate what is the percent growth in an account over 1 year. That is your APY. All right, so let's do a quick example. Well, I'll do 2 examples. So you either are given this or this, and you can calculate effective annual rate. And you can calculate the other one also. Okay, so let's say we have a 3% continuous annual rate. So my amount in my account would be P e to the 0.03 t. You just put in the continuous annual rate for R. Okay. And P is your initial investment. I didn't tell you what that was, so let's just leave it as P for now. All right, so if I would like to know the APY, or the effective annual rate, that is how much money does this bank account make over the course of 1 year? What is the percent gain, percent increase? So let's just pretend that we invest $100 into this account for 1 year. So 100e to the 0.03 times 1. So we're just going to invest $100 for 1 year and see how much money we make. 100 times e to the 0.03. So I get $103.04. So what is the percent increase on this bank account that started with $100 and finished with $103.04? 3.04%. So my APY, or my effective rate, is actually 3.04%. Okay. So my continuous annual growth rate is 3%, but effectively I make more than 3% because of the continuous compounding, because you make interest on the interest. A just stands for like amount in the account. Amount. So A is the amount of money in the account, and it's always equal to the P, which is the amount you initially invested, times e to the RT. R is your continuous annual growth rate. I can't remember, did we do like compounding monthly and quarterly and stuff? Okay. All right, so if I compound, let's say I have a 5% annual rate compounded monthly. So I want 2 things. I would like to know the effective annual rate and what is the equivalent continuous annual rate. Okay, so we'll start with part A. So if I have a 5% annual rate compounded monthly, my formula for compounding n times per year, it's A is equal to P times 1 plus R over N to the NT. So in our case, we have P times 1 plus 0.05 over 12 to the 12t. So if I want to know the effective annual rate, I'm just going to invest in an imaginary $100 for 1 year. And I want to know how much the account grows. So I put in 100 for P. 1 for T. Invest $100 for a year, and I want to see what is my percent growth. So 100 times 1 plus 0.05 over 12 raised to the 12th. So I get $105.11. Okay, so if I started with $100 and I finished with $105.11, what is my percent growth? 5.11%. So my APY, which is also called the effective rate, is actually 5.11%. You end up making a little bit more than the nominal rate of 5% because of the compounding, because you make interest on interest. So this is an important thing if you ever are opening an account or taking out a loan, to find out the APY. It's by law, the bank has to tell you that, and it helps you compare things. But often what they advertise is an APR, so you need to ask for the APY or look for it. Okay, so B, I would like to find an equivalent continuous annual growth rate. Okay, so I have P times 1 plus 0.05 over 12 to the 12t. I would like to figure out what is that R value that makes these two things the same. What continuous growth rate is the same thing as a 5% growth rate compounded 12 times per year? So what APY, what continuous growth rate would make a bank that offers something compounded continuously the same as a bank that offers 5% compounded monthly? So what interest rate would make these two accounts have the same APY, the same effective rate? Okay, so let's simplify the left here a little bit. 0.05 divided by 12 is 0.004. So they both have a P on each side, so those can cancel. So this is 0.00416 repeating to the 12t, and I want to know e to the rt. They both have a t in the exponent. Those are the same on both sides, so I'll just get rid of them. Oh, yes, thank you. Thanks. Yeah, I might need that. Okay, so they both have a t in the same place on both sides. I'm just going to get rid of those. Okay, so now I would like to know 1.00416 repeating to the 12th equals e to the r. E to what value? So how do I solve this thing for r? Take the natural log of both sides. So this thing is just a number, this 1.00416 repeating to the 12th. It's just a number, and that equals r, because the ln of e to the r is r. Take the ln of both sides. Okay, so oops. I'm just going to add 1 to this. So I'm not rounding anything. I'm just keeping that number as it is. Raise it to the 12th, and then take the ln of it. And I get 0.04989. We'll just say 0.0499, round it, which is 4.99%. Right? That is my continuous annual growth rate. So if a bank compounds continuously, they can offer a slightly lower rate of 4.99 nominal rate. Nominal rate. of 4.99 versus the bank that compounds monthly offering a nominal rate of 5%, when effectively those two accounts are the same. They'll make you the same amount of money. There's a circle. It's got radius 4. I created a central angle that has angle pi over 6, which is the same as 30 degrees, right? I want to know this arc length S. We often use S for arc length. So we have this formula that S equals R theta. As long as theta is in radians, you can use this formula. It only works in radians. So all I have to do is take S is 4 times pi over 6, and I get 2 pi over 3 is the arc length. Yeah, that's a good one. This formula comes directly from the definition of a radian, that 1 radian is equal to an arc length on the circle created by when the arc length is equal to the radius. So if this is my radius R, if I have an arc length, like if I had a piece of string to lay along my arc length that's equal to R, this is 1 radian. So if I used this formula, S equals R theta, you know, my arc length is R, my radius is R, then theta has to be 1. If it's given in degrees, you have to convert it to radians and then use that formula. Yeah. Yeah, you could create a formula that uses degrees rather than radians. Yeah. You could say, okay, well, 30 degrees out of 360 degrees, right? That's the fraction of the circle. This radius is 33, I'm sorry, this arc length is 33/60ths of the whole circumference. So I could multiply that fraction by the whole circumference of this circle, which would be what? 8 pi, 2 pi r, right? So you could take 33/60ths of the whole circumference, and you're going to get the same thing, 2 pi over 3. So you can do it that way also. Figure out what fraction of the circle this arc length is, and then do that fraction times the entire circumference.